Okay, so good afternoon, everyone. Dr. Jensen here. So today we are going to look at a few practice problems dealing with some more complicated units. And so this is generally seen in the second semester of chemistry, where we're looking at things like molarity, molality, weight percent, and mole fraction. So we're going to look at two problems here because these tend to be a little bit long as you look at several problems here. Okay. So a solution where we have 133 grams of sodium chloride is diluted and the total volume of the solution is about 1 liter. We want to calculate the molarity, the molality, the weight percent of the solution. So we assume the solution has a density of 1.808 grams per milliliter. Okay. So the first thing we need to know in pretty much all of these, I mean, with the exception of weight percent, but at least in the first two, we need to know the moles of our solute. So we have 133 grams of sodium chloride. Okay, there is 58.44 grams per mole. Okay, so that means there are a total of 2.28 moles of sodium chloride. Okay, so molarity is the easiest one here. Okay, so capital M molarity is moles of solute per liter of solution. Okay, so we have 2.28 moles of our solute in 1 liter of solution. Okay, so our molarity is 2.28. Okay, that was pretty easy. Okay, weight percent. So if we have 133 grams, okay, and we have 1 liter of solution, okay, so the total then, okay, so weight percent is always the part over the whole, right? So if the whole solution is, so we have a solution volume of 1,000 liters or 1,000 milliliters, right? So we have 133 grams in 1,000 milliliters. Okay, but we want to know the mass of the solution because this is the solute over the solution. So the total is the solution, but we want to know mass of both. So we have the density. They gave us the density. So we're told that in 1 milliliter there is 1.08 grams. Okay, and so this would translate to grams of solute over grams of solution, right? And that's really what the weight percent is grams of the solute over the grams of the solution. So we get 133 grams in 1080 grams. Okay, so weight percent is then times 100. So we have 12.3% by weight. Okay, molality. Okay, the last one here. So molality is the moles of solute per kilogram of solvent. Okay, so something to keep in mind here. So this is a critical step in solving this part because we don't really have any information about the solvent. So we have to remember the kilograms of plus the kilograms of solute equal the kilograms of solution. Okay, the solvent plus the solute make up the solution. Okay, so if our solution here is 1,080 grams, our solute is 0.133. Sorry, we probably should put this in. No, it doesn't. We could do it in kilograms, but let's just move this. Okay, so it's 1.00 kilograms, 0.133 kilograms. Again, this is just moving the decimal place 3 times. And then the solvent is our only unknown. Okay, so we'd subtract out the solute, and so our kilograms of solvent are 0.947. Okay. So now we can go back here to, we have the moles, 2.28. Okay, again, that's still our solute amount, but now we have the kilograms of solvent as 0.947 kilograms, which gives us a 2.41 molal solution. Okay. In this is probably a critical step here, is if you don't remember this association here, that the solvent and solute equal the solution, then it is often difficult to parse out what is the kilograms of the solvent, especially when we're told only about the solution. All right, so go one more. Same kind of thing. This one's a little bit longer. So here we have a solution of 28.4 grams of glucose in 355 grams of water. The final solute volume of the solution is 378 milliliters. We want to know the molarity, the molality, the weight percent, the mole fraction, and the mole percent. So the mole percent is not really anything different than the mole fraction. It's just times in the mole fraction by 100, but we'll get there. Okay. So our molality, or our molarity first. Okay. So first we need to know, so we're given, we have 28.4 grams of the glucose. Okay. There is 180.16 grams per mole. Okay, this is the molecular weight, right? Now we're told that our total volume is 378 milliliters. So this is 0.378 liters, right? So this tells me my moles per liter, which is my molarity. So this is 0.417 molar. Okay. Molality is going to be very similar here. Here they already gave us the mass of the water, the mass of the solvent. So again, this takes some of the bricks out here. So we got 2.84 grams of glucose. Okay, again, the molecular weight is 180.16 grams per mole. But now my kilograms of solvent are already given, or given close enough. So 0.355 kilograms. Okay, multiply on the top, divide on the bottom, and we get 0.44 molal. Okay. Weight percent here, again, is part over the whole. So the part is the glucose, okay, is 28.4 grams of the glucose over the total mass of the solution. So we're told that the solvent is 355 grams, right? But we also have to add in the solute in there again. So it's 28.4 grams for the glucose. So this is the glucose plus the water equals the solution, right? Times 100, and we find that there's 7.41%. Okay, so the part over the whole. So the whole thing is the solute and the solvent. Okay. The next thing we want to look at then is the weight, is the mole fraction. Okay, so mole fraction, so this is just like you would have done in a previous gas chapter of solving for the mole fraction. So the mole fraction is the moles of A over the total moles of the system. Okay, so we need to know the moles of each one of the components. Okay, we need to know both because in order to get the total moles, you need to know both A and B, right? So in this case, we have 28.4 grams of glucose. There's 180.16 grams per mole. And there's 355 grams of water, about 18 grams per mole. So we get 0.1576 moles and 19.7 moles. Okay, so our total then, okay, if we add these two together, our total then is 19.86 moles. Okay. So then the mole fraction for glucose is the 0.1576 divided by 19.86. Okay, just for the mole fraction, we're not multiplying by 100, it's just the total, the part over the whole. Okay, so we get 0.00794 is the mole fraction. The percent mole fraction is 0.00794 times 100. Okay, so there's a lot of information to try and do all at one time, but we should be able to do any of these kinds of calculations within when we're dealing with solutions, converting between these different units. Okay, all right, that's it for this video, and we will be back again later with some more.